Today we're going to look at the most important things that Mariner 10 discovered. Trust me, it's good for you to watch this video because, let's face it, you can't just hop over to Mercury to check it out yourself. But thanks to Mariner 10, we've got all the cool details you need. NASA's Mariner 10 was launched on November 3, 1973, and it was the first spacecraft to visit Mercury, making its journey to the planet in the 1970s. The primary goal of the Mariner 10 was to study the atmosphere surface and physical characteristics of Mercury. Soon after leaving Earth orbit, the spacecraft returned striking photos of both Earth and the Moon as it sped to its first destination, Venus. Over the course of its mission, it completed 3 flybys of Mercury between 1974 and 1975. One of the most significant achievements of Mariner 10 was that it was the first spacecraft to take detailed images of Mercury's surface. It sent back over 2,000 images, revealing a world that looked similar to Earth's moon, with many craters resulting from impacts by asteroids and comets. The images showed a heavily cratered surface, suggesting that Mercury had not changed much over billions of years. Among its most important findings was the discovery of the Caloris Basin, one of the largest impact craters in the solar system, measuring about 960 miles in diameter. Mariner 10's images showed the basin's circular structure, which was surrounded by a mountainous ring, revealing the immense power of the impact that created such a feature. The spacecraft also revealed various geological features, including vast plains and ridges. It found that some areas appeared to be smoother than others, indicating that these regions may have been covered by lava flows in the past. Mariner 10 captured images of scarps, which are large cliffs formed by the shrinking of Mercury's crust as its core cooled and contracted over time. One of the most surprising discoveries was that Mercury has a magnetic field, which is unusual for such a small planet, as the magnetic field is about 1% as strong as Earth's. This finding led scientists to believe that Mercury must have a partially liquid outer core, which is necessary for generating a magnetic field. This was unexpected because many thought that a small planet like Mercury wouldn't be able to maintain a magnetic field. Mariner 10 also detected a very thin atmosphere around Mercury, known as an exosphere. This atmosphere is composed of particles such as helium, sodium, hydrogen, oxygen, and potassium. Due to Mercury's closeness to the Sun, solar winds constantly blow these particles away, preventing them from forming a stable atmosphere like Earth's. This thin atmosphere is continually being replenished by particles from the surface and solar radiation. Mariner 10 provided valuable data about Mercury's temperature, showing that the planet experiences extreme variations. During the day, temperatures can rise to about 430 degrees Celsius due to the Sun's intense heat, while at night, temperatures can drop to around -180 degrees Celsius because there is no significant atmosphere to trap heat. While Mariner 10 couldn't capture detailed images of Mercury's polar regions, it did provide some data suggesting that these areas might contain water ice in permanently shadowed craters, similar to those found on the Moon. The spacecraft detected hints of cold regions where sunlight never reaches, which could preserve ice. The images captured by Mariner 10 showed that Mercury's surface is covered with a layer of regolith, which is a mix of dust, soil, and broken rocks. This regolith has been altered by impacts and possibly by the solar wind, which can change the chemical composition of the surface materials over time. Mariner 10 confirmed that Mercury has no moons or rings, likely because the planet's weak gravitational pull and its proximity to the Sun would make it difficult to capture or hold onto these objects. Because Mariner 10 was a flyby mission, it was only able to map about 45% of Mercury's surface in detail, repeatedly viewing the same side of the planet during each pass, which limited the overall data gathered. However, the information it collected was crucial for enhancing our understanding of Mercury and laid the groundwork for future missions.